Here we have an application of cross products. So we use cross products to compute the magnetic force on a moving charge. A charge here you can think of an electron or proton. So moving electric charges experience a force when they pass through a magnetic field. So assume that we have Q, the quantities of charge. So the unit is in coulombs. So for example, an electron had Q equal to minus elementary charge, so minus 1.6 times 10 to the minus 19 coulombs. A proton has Q equal to exactly E, the elementary charge, so 1.6 times 10 to minus 19 coulombs. We have Q charge, okay, and we have V here, the velocity of the charge, and we have vector B denote the magnetic field, and the force that the moving charge experiences when passed through the magnetic field is computed as vector F, vector force, equal to Q times the cross product velocity cross the magnetic field. So the magnitude of the force is absolute value of Q times, so the length of V cross B, which is absolute of Q, length of V, length of B, and the sine of the angle between V and B. So theta, the angle between V and B. So we use this formula to compute the force of moving charge. We have Q charge here, and the velocity is a vector, say vector velocity here, V. And at this position, the magnetic field vectors B, like this, then the force will be the Q times the cross product of V and B. So the cross product of V and B is the vectors perpendicular to both of them. So by using the right hand rule, you can see that the force is actually pointing down in this case. Here's the force F. So F is Q times V cross B. Vector V cross vector B. Now here's an example. A particle with unit charge. So we have Q equal to 1 in this case, enter a constant magnetic field. The vector B, the vectors denote the magnetic field is a vectors I plus J. So we are in 3 dimensions. So you think of 0 times K with the velocity V 21K. So vector B is vector 1, 1, 0. Vector velocity V is 0, 0, 21. You can draw the exact graph, so we can have, let's say, X here, Y here, and Z here. B, I plus J 1 1 0. So here's I. So 1 1 1 here. So vector B look like this. Let's say this one is vectors B. And then we have vector V is velocity 0 0 21. So say vector V so look like this. Yeah, so assume this is 21 here. Vector V. We need to compute the magnitude and the direction of the force on the particle. Okay, so by our formula we know that the force is vector F is computed as Q times vector V cross vector B. So as the formula we have here. Now we need to compute the magnitude and the direction. So there's say two methods we can do that. So the first method you just compute the cross product directly using the formula of the determinant. So in our case we have Q is on, right? V cross B. So because Q is on, this is exactly V cross B. So all we need to do is computing V cross B where V and B are given to us like that. So let's do the first method. Method 1. Compute V cross B. So you write down the first rows is I, J, K. The second rows correspond to vector V, so we have 0, 0, 21. And the last one is 1, 1, 0. So by doing it quickly, we have I, 0, 21, 1, 0, minus J, 0, 1, 21, 0, plus K, 0, 0, 1, 1. So this gives us 21 I minus or plus 21 J plus 0 K. So the vectors V cross B or the force equal to vectors 21, 21, 0. So with that you know it should be 21, 21, 0, 21, 21, and 0. Minus 21, I. Minus minus plus 21, J. 0, K. Vectors minus 21, 21, 0. So this is the fox we need to compute. In the pictures, the fox would look like so. The fox 21 minus 21, 21, 0. So minus 21 is here, right? X. This is x-axis. So minus 21 has to be in this direction, the negative direction. Minus 21, assume that is this point. Okay, minus 21, say 21 in this point, so somewhere there, right? And then 0. So if we sketch the fox is good look like, for example, minus 21, 21, 21 here, minus 21 here, and 0. So here's the fox. Vector F. And we need to compute the magnitude and the direction. So the magnitude of F is the length of F. So the length of these vectors which is square root minus 21 square. So 21 square plus 21 square plus 0 square. So we have 2 times 21 square. So this is 21 square root of 2. So this gives us the magnitude of F. And we need to compute the direction. So here's the direction of F. You can see it right here. One way you can say this is because we know that z coordinates is 0, so it's on this plane, right? On the xy plane. You can compute the angle between x-axis and vector F. So the angle of between F and the x-axis between vector F and OX. So this is the positive x-axis. So you go from origin to x, positive x-axis. So again, we have say different methods to do that. One way is you can compute it directly from formula, and the other way you can see from the picture. This has to be 135 degrees. How do we know that? So this is -90 right here. This side 21, this side 21. So this angle is 45 degree. So 45 degree plus 90 degree. So we have 135 degree. 135 degree. So 90 plus 45. So that is the first method. We know that angle has to be 135 degree. The second method you can also use by the formula. We can also compute the angle. By formula. For example, we can use a dot product. So we know that vector f is this vector. The vector I, the one correspond to the x-axis, the positive x-axis is 0, 1, 1. So you can compute that using formula A cross A dot B is length of A, length of B, cosine the angle between them. So we can compute A dot B. So in our case, this is minus 21, right? Because 0, 0 here. Length of A, we know that is 21 square root of 2. Length of B is length of I is 1. So we can find the cosine of the angle theta. Right? So we know that the angle between I and vector f is theta. Cosine of theta is the dot product f dot I divided by length of f times length of I. So f is a vectors minus 21, 21, 0. I is 1, 0, 0. So minus 21 divided by the length of f, 21 root 2. Length of I is 1. So this is minus 1 square root 2. This means that cosine of theta is minus 1 over square root 2. Theta is 135 degree. So either way, we know that the angle has to be this. We have the length and the direction of vectors. So in case we don't want to compute this formula, we can also compute the magnitude of f by, okay, so magnitude of f is magnitude of this cross product. Magnitude of f is magnitude of v cross b, and we know that it is magnitude of v, magnitude of b, the sine of the angle theta. I only use theta for this, so let's use sine of the angle alpha. Okay, alpha is the angle between V and B. And look at the picture we have right here. V here, B is here. So V on the x-axis, right? So this angle is 90 degree because z-axis is perpendicular to xy plane. So the angle between them is 90 degree. So sine of 90 degree is 1. So the magnitude of f is this magnitude of f, length of v, length of b. Length of v is the length of this vector, so let me copy v and b here. Length of vector v times length of vector b. So the first one, the length of this vector is 21. The length of this vector is 2, square root of 2. 21 times square root of 2. So yeah, so either way you obtain the magnitude of f is 21 square root of 2. The angle between f and OX, the positive x-axis, is 135 degrees as we have done before.